Daniel, how you doing?
Good. How are you?
Doing very well, doing very well. Thank you very much for joining us. Yeah, can you go ahead and just let me know kind of what's up with the Yonder Deep and what you've been up to?
Yeah, sure. So, like I said, my name is Daniel. I'm the current president of Yonder Deep. We're currently a student organization at UC San Diego, also based out of Scripps Institute of Oceanography. We're working towards developing a 3D printed autonomous underwater vehicle, or AUV, primarily for oceanographic research. And with this goal in mind, we're working in collaboration with a physical oceanographer, Grant Dean, at Scripps Institute of Oceanography, to develop our AUV for deployment in Svalbard, Norway this summer for climate change research, which is really exciting. We'll be collecting acoustic data, which directly tells us how fast a glacier is melting and ultimately translates into the rate of global warming. So yeah, that's just been our project the past few years, and we recently partnered with Raise3D, and we're excited to work more with them. We actually partnered with the oceanographer Grant Dean I mentioned about 5 years ago, and we've been working on the same project for about 5 years. And yeah, with him, he's just really been focused on climate change research. So, and I guess a big thing for him, like a background in glacier research, is that getting up close to the terminus of a glacier is really dangerous when you have 200-foot tall calving events happening. You obviously don't want to be underneath that. So for him, gathering acoustic data at that level is really important. And so getting that data requires an AUV, and that's sort of transformed how the entire research community has been gathering this data. But the problem is these AUVs can range from like tens of thousands of dollars to hundreds of thousands, even millions, depending on the capability. So we're really just here to change that, make it more accessible, entry-level research more accessible. And yeah, that's where we are today.
Absolutely, yeah, just kind of going for it on more of a limited budget, and you still are looking to do the exact same thing. But really, what is the exact process? What are you guys doing? You said you're getting acoustic data. What are you looking for? What kind of hardware is involved in collecting that? And how does that translate into the actual AUV?
Sure. So really for this specific mission, the main tool or the sensor we have are hydrophones. It's these really small instruments that are basically, I guess in layman's terms, like underwater microphones, really. They can capture like the decibel level, quality of a bubble, things like that. Yeah, really our process so far has just been first developing a general purpose 3D printed AUV, and then designing to make it more modular to account for different types of sensors depending on the mission. So like, let's say we wanted to throw it in the waters of San Diego, we could change the sensors around. It'd still be applicable, and same thing with the Arctic waters of Norway. So that's really been our whole mission so far, just developing an AUV first. Yeah.
Yeah, and going with the modular design, like you said, it's going to be used for, or at least should be used for, research in multiple different areas. So it just opens up and broadens what these things can be used for, essentially bringing down that budget, like cheaper, easier to use.
Right.
What has been the process so far, walking through like the productions of getting the AUV working? What's the prototyping like? What's your workflow like?
Sure. I guess I'd go back in time a little bit, just from like when we first started. Really, the first few years were kind of difficult, I think. It was a lot of testing, just trying to see like how much we could have 3D printed. Because I think if you see like normal AUVs out there in the market right now, there's very solid metal coated things like that. It's pretty difficult to work with that type of material, and so also plastic in cold water is not the best combination. So there's a lot of testing that needed to be done. So the first 2 years were spent prototyping. We made small scale versions of our AUV just as a proof of concept and seeing if our motor configuration would work. And then recent years, about 2 years ago, we started actually developing our full scale AUV, which is about 2 meters long, I think. And that's been, I guess, that's when we actually reached out to Raise3D, because we noticed that, scaling up production and having parts that like at least a foot tall requires a large format printer that wasn't possible before. So yeah, we've just been developing the past 2 years, running pool tests. It's been going good so far. I think we're on a good track.
Nice. When going into those prototypes and looking at kind of more of the printed parts, what are the considerations that you're looking at specifically for the AUV, and how do those translate into specific like design changes or types of settings that you're using for printed stuff? I'm assuming you're not just using the default settings that everything has set up.
Yeah, so one of the big things we actually are still looking into is whether or not we want to flood the part with water, because the only way to prevent against flooding, I guess, would be like having parts be 100% infill, which obviously that's not the best economically, or also like in time wise, it takes a long time.
Yeah.
So yeah, we've been just working to experiment with like PVAs in some cases helps make those like bottom supports or bottom faces that touch the ports a little bit stronger. Also been looking into coding as well and looking into different types of materials. We're still experimenting with other types, I think, and open to looking into other ones. But yeah, mostly so far we've just been looking into like materials, coatings, and things like that.
Yeah, and so thinking about like 3D printed parts plus a coating, comparing that to another method of getting the parts, how do you think those two would stack up? Like if you were to have it injection molded and then shipped over, what would the performance expectations be versus, you know, the printed and coated part?
For something like that, I think it would be mostly a cost consideration and also ease of design, I guess. So I can go into two different methods I think that you could potentially be thinking about. So one would be the injection molding. I think the tooling for that would be quite expensive just to make the mold, and then, you know, having that made and also only making one part of that. That'd be, I don't think it'd be economical for us. And also, like, let's say we use CNC machining or just manual machining. Our parts are pretty complex in their geometry. So having that made with CNC machining will probably take a few months at least. And while when we have it 3D printed, we can have all these complex geometries and different layouts and stuff that we can really print in like a turnaround time of a few days. So that's been really beneficial for us.
Yeah, so the faster turnaround time and then also the ability to work with higher complexity, but still have pretty easy with the machines, definitely.
Exactly, yeah.
Yeah. When exactly was, like, what's your experience with the printing so far? You said it was prototyping. Were you always printing from the beginning, or did it kind of factor in and then change things later on?
We were mostly printing from the very beginning, I believe. I think we just really liked how customizable it was, or we started with prototyping and that usually just came with 3D printing, having parts being easily changed. And then we found out, I think later on, that it really just made more sense to keep 3D printing just because of the ease of use and like how cheap it was compared to other methods. So yeah, it really just stuck with us and we just built along with that mission in mind.
Yeah, just kind of going with having the printer in the process from the beginning just kind of has benefits all the way through.
Right, yeah.
Like education, you guys are part of the university. That should have effects out into like the other classes. It's not used just specifically for making AUVs. What do you think that's like working with it in other classes or just having it accessible in other labs? What's the broader benefit?
Yeah, so in education in particular, I think it's incredibly important. For students, you know, it's, at least for mechanical engineering students, it's very important for them, I believe, to get a grasp on the design mindset first, and then usually understanding how manufacturing and stuff comes into play later. And usually this design experience, like learning how to think before you design, is sort of something that comes with experience. And so I guess just as an example, like compared to CNC machining, 3D printing is a lot more forgiving in, you know, what you can design and how you can sort of design your model around that type of machining. And so it's more acceptable to learn as you go in 3D printing. Like if you have something misaligned, it's really just a turnaround time of, you know, really cheap plastic and then maybe a few hours. While if it's CNC machining, you gotta wait a few weeks and then go through the whole complicated process again. So I think there's a lot of benefits in 3D printing, at least in the design field. Just teaching people how to think first is really important. So yeah.
Yeah, and that is probably one of the bigger things in learning and getting started in the manufacturing, or just if you wanted to test out new things. The flexibility of the machines, and then of course the low cost and just less waste material overall because of the additive manufacturing process. All, again, just kind of continuous benefits the more you use them and the more you incorporate it into like prototyping. Just reduces the time and things. Kind of like, what are we looking at going forward with you guys? Like what are you gonna be printing on machines? What are the next steps for Yonder Deep?
I think it'll mostly be sort of finalizing the parts we decide to use. So we're still kind of in the prototyping phase. We've had about 2 or 3 working prototypes, but ideally we'd like to get something finalized, and then obviously for those parts, we're gonna focus a lot on like the final print quality. Like we won't compromise anywhere. So with Raise3D, at least with the printers, I think we'll be working a lot on tuning it in. It's already pretty tuned in, but like just if we want to change materials and stuff, we'll have to tinker with those settings and everything. Yeah, we'll just work on making our final parts definition ready with the printers.
Yeah, actually, I do have some of your parts here. Do you want to kind of take a look at them in Idea Maker and go through what it would be like to print them for your guys' application?
Sure.
Sweet. Okay, cool. Which file do we want to bring in?
I think the nose cone or the front whole motor end cap, either of those could be good.
Okay, both excellent choices. I'm going to go with the full motor end cap. Be a little bit quicker swing.
Real quick, this sort of just goes to show like the type of parts we're working with, and CNC machining this out of like a piece of aluminum would be really difficult.
Yeah.
And also be pretty heavy. So yeah, that's sort of what I opted for 3D printing. But anyways, so yeah, with something like this, we really just place it on the flat face you see here.
Yep.
On the left side here, or yeah.
Then go ahead and just lay flat, or the 90-degree rotation snap. Either one will work. We're basically running it like this.
Yeah, so I guess this part's relatively simple in its design. I think if for our final version, we might put PVA into some of those like little slots on the side. Those are for cable pass-throughs. Yeah, really, I guess this part isn't too complicated, but this is just a good example of one of the complex geometries we'd use.
Yeah.
That really wouldn't be possible without 3D printing.
It's definitely a lot of the things in here, like going around outer end. It could be CNC machinable, not too bad, but like we said, the weight considerations like this is cable pass-throughs. Is this going to be used? I'm assuming this one isn't actually on the exterior of the vehicle, right? Is this internal?
Yeah, most of this is internal. The slots feed from the outside, but yeah, it's mostly internal.
Yeah, so if it's all mostly internal, then if we were to do this out of aluminum again, it'd still be pretty lightweight, but by printing it, we can essentially get it down to, here, I'll just slice it really quick for like ABS, it looks like, or just the part itself. If we're running it with our default settings, 15% grid infill, good for you?
Yeah.
All right, cool. Go ahead and leave that. And then I'm leaving the supports off of this one specifically, just to get a read on the part material. So then things like this, even having the slicing ability or having the slicer give you the ability to just give you estimates on things like that. I'm not needing to go through and really kind of look at what's the total volume of the part, what's the density of aluminum. It basically just kind of is part of the printing process to really get that information. Okay, we're looking at 187 grams, just a little bit. And then all of this would still be structurally sound enough for just holding those components, not taking any water pressure. Even if it was, that kind of outer treatment for it just needs to keep that water out. The internal structure could still probably not be 100% density because we're compensating for the sealing of the parts with a different combination. And then I wanted to take a quick look at the nose cone. I might not reslice this one, but the nose cone itself, walk me through like the purposes of this part and what you would be thinking manufacturing versus printing and then traditionally.
Yeah, so this part is really difficult. I think the manufacturer wasn't to be 3D printed. Like this big gap in here.
So there we go. So I've got the interior of it going through here, and it is all pretty much empty except for this section here that crosses through the middle.
Yeah.
Yeah.
Yeah. So this is definitely, we might have to make this in multiple parts even if we wanted to have it machined. But yeah, just the overall shape of it is more organic, I guess, in that sense. So I think that's another benefit of 3D printing. I think even people in the industry do things like topology optimization, making things, specifically for 3D printing that's like organic. But yeah, this piece in particular, that big hole is for our left and right turning motor. So it's also a little bit, or the piece that it's connected to is a little bit load bearing. Yeah, there's a lot of considerations, just like this piece at least for printing, like that bottom base. We usually print it in the configuration you have right now, and so that bottom piece usually needs PVA supports.
Yeah.
And then it usually ends up a pretty good finish.
Yeah, down in here, I would imagine that using PVA for things like this, all of these bottom surface details, definitely want to use that. Have you seen the modifier bodies on this yet?
I have not.
No? Okay, cool, awesome. I'm just really glad that I get to be the first one to show you. So really what I'm thinking of for this base, if we want to reduce material, print time, things like that for these parts, but still strengthen it in that area where it's going to be mounted, I can go ahead and we'll close our cross section. That up anyway. And then modifiers. So I can go ahead and if I had this STL file, I would kind of want to import in maybe just a section of it because I can pull in a specific STL from local disk. But just for this one, the main point is anywhere that I have this modifier body, I just selected this one, modifiers at the top, add in a modifier. Anywhere that this part body is overlapping with the modifier bounding box, it is going to change the parameters of the part, but only in that specific region. So I'll go ahead and up so it covers a bit more of the base. We'll put it in the center, change our scaling a little more so we cover the entire bottom area. So I have a modifier overlapping the region where I want. We can set it to change the overlapping settings of the parent model. We can also run it as support structure if we wanted to have a really specific support orientation or design, or support blockers. So we can put them, if I wanted to not have supports on this arch, I could put a modifier through that region. As long as those surfaces are within that bounding area, it will not generate supports for those areas, but it can hit everything else. But just for this one, we'll do change overlapping settings. And then for this section, I can really just increase the infill density. We can change the pattern type too if we want. So we'll run, say, a honeycomb structure. We'll do a 5%. I'll go ahead and slice this with named. So again, still no support structure just because I want to see that infill. But this should allow us to have just that bottom section.
I'm assuming also with the modifier, you can also change things like variable layer height, I guess, things like that.
We can change certain areas. Usually, I believe the layer height has to go for the entire layer. That one's a little tricky. It is possible to use or like to assign certain sections to the left and right extruders and have each nozzle running a different layer height. That's a little bit easier, but or doing like a combined infill. That's something that we can. We're printing like the outer shells in a lower layer height for the extra smoothness or the extra better surface quality. So printing like the outer shell at a 0.2 off of one nozzle and then printing with a 0.8 on the right. And then we could run the infill at a 0.6 and that just cuts down on the print time and total amount of infill layers. But for this one, what I want to get into, a lot of this is the structure. Yeah, really useful. Yeah, it is. It's really, really useful price. I gotta say, it's one of my favorite features. So yeah, so then getting down in here, all of this is running that higher density. We'll have more strength in areas for the mounting, but the rest of it beyond that point goes down to 15%. Basically, just using for the rest of the body. And then I think we're basically just kind of gonna have more things going on. You have your machine. We're going to bring it down to you pretty soon, and then we'll be doing probably a lot more, just catching up and being a part of the process and the project. So we'll keep everyone else updated, probably in future streams, future videos for sure. And yeah, we'll be seeing a lot more of Daniel. But anything else you want to wrap up on?
Not much. Just really excited to work more with Raise3D. You know, so far it's been really supportive in our project, and our missions align pretty well. So yeah, looking forward to working with you all more.
Yeah, absolutely. Yeah, I think it's going to do it for us for the stream today. Again, Daniel, thank you very much. We'll definitely be talking later for sure. And then thank you very much for everybody who tuned in. I hope you liked hearing us talk about AUVs and printers for this long. But we're going to go ahead and end it here. We'll see everyone else in the next stream.